Hello, I'm Hawker from Ashford Music Tools. I get a lot of requests asking me what it takes to calibrate and test a ADG-1 analog delay and how to calibrate a Bbd bucket. So I'm going to do that very quickly. We have with us here an analog delay fresh off the manufacturing line here. And I have a power supply, a voltmeter, an oscilloscope, and an audio tool running a program called ADG to look at what we're doing. So, and this shows my voltage and my current. So when I turn it on, the first thing you'll see is my voltage and 82 milliamps. And then we're going to check the voltages on this side. So first we're going to check the Jfet voltage. I should say this is a 15 volt power supply. So everything's right around 15 volts. This is checking the control voltage bias. This is the mid-rail bias. And this is my analog voltage. And this is my clock voltage over here. And this is a good way to check power consumption by looking at the drop across the PTC. And I'm going to check the bias on the bucket from this side because it's easy. Once that's done, I'm going to flip this over and I'm going to check all the voltages on the main board. This is the main board. It has over 400 surface mount parts on it. And I'm going to check all the bias voltages very quick, paying particular attention to the compander, which is kind of a low tolerance old part. And there I can see it's good. And I'm going to check the filters. They have a little bit lower voltage on them. And then I'm going to check the bias voltages. And once I know all that's good, I then will use the oscilloscope and a probe to set the clock. And the clock is how we set the delay times. So the first thing I'm going to do is I'm going to set the shortest delay time. And that's by getting a clock at about 125 kilohertz. I like to make it a little bit long so that we can guarantee you get all the range possible. And then I'm going to set the shortest delay time, which is a little over 700 milliseconds. But I do that again by setting the clock to about 5.82 kilohertz. Once that's done, I double check both of them. And then I set it to a good mid-range frequency. Most people use between 20 and 25 kilohertz, so I've split the difference. And I set it to about 25.5 kilohertz. And since I'm checking frequency, now's a good time to check some other functions. And so, hold the board like this. We have a delay section, a low frequency oscillator section, and a level section. And I'm going to crank the amount on the LFO section, and I can see it's not doing anything until I engage it. Once I engage it, the clock will move. I'll set it to square wave so it snaps quickly, and I'm going to check the bottom range of the modulation and the top range, and I can see it's working fine. So then I can turn it off. Below me on the pedal I have an expression pedal, and I have this set in that. So using my foot, I should be able to get the same range, a little below 10 kilohertz, and a little above 53 kilohertz. I then, using my eyes, I use the rate, and I check that it's going just a little faster than my eye can see. I then set the expression pedal. Sometimes the first time you turn these, they're a little bit tight. And using my foot on the expression pedal, I can watch the LED change at the same rate. And then I can flip this over and watch the clock change using my foot. Again, I know the range. And now we'll set this over to feedback, the expression to feedback. So we have, with our foot, we can control all four of these knobs. So I set it to there, and we'll get back to that later. And now is the part that everybody wonders about. It's the Bbd calibration. The first thing I do is I maximize the gain on the Bbd right there. And I have to set this to a little bit different setting. And I'm going to use ADG over here as a signal generator. So I'm going to put a signal in. And there is an uncalibrated Bbd. I like a 400 kilohertz signal. Some people use 1 kilohertz, some use 500 hertz. I just find 400 works better. And I use a triangle because it's easier to see clipping. Now, if your analog delay has a gain section like mine does, you can use it. And you'll notice that right off the bat, it's flat on the top and it's not on the bottom. And that means it's not biased. So it's very similar to biasing a tube amp. We're going to adjust a trim pot here for the bias until the top and bottom clip about the same. And then I like to take the gain up and down to make sure that they just start clipping at the same amount. So that's the first part of biasing a BBD, is biasing so that the top and bottom clip at the same point. The second part, if you kind of look, there's a fuzz on here, and that's clock fuzz. This is not easy for all digital scopes to see, but you'll notice if it's out of spec, it's very fuzzy. And the idea is to just dial, there's two parts to the output, and we're dialing them until they're as close as possible and the fuzz goes away. Some people like to increase the scope and watch these two outputs and make sure they're the same. But if you've done enough of these, you can do it in this. This is definitely one of those places where an analog scope shines, but the newer digital scopes can handle it. Once we've done that, I'm going to move over to the second BBD and do the same thing. Oh, I will say, notice I am right before clipping, and then I move to the second BBD, and I'm going to do the same process on this one. I'm going to adjust it until the top and bottom look about exactly the same. And while I've got my stick here, I'm going to adjust that fuzz part. You'll notice, see, it was kind of fuzzy to start with. And as I do that, I get rid of the fuzz. And that's clock on top. And that helps the clock reconstruction filters work better by nulling it out there. You will notice if you've done other BBDs or other delays that I have less clock noise than most. And we have a little process that is unique to the Ashford Music tools that gives less clock noise early on. And at that point, the BBD bias and offset is calibrated. So now we have to calibrate the levels. And classic companders and BBDs are not very accurate in their levels. So in order to have your feedback accurate, we either need to calibrate the level, or we need to, of the BBDs, or we need to calibrate the feedback. And I prefer to calibrate the BBDs so we know what we're dealing with. And the way I do that is I set this to a very low voltage before any clipping goes on, and I like about minus 15 dBV. So I've set it to minus 15 dBV. If your delay has a limiter on it, and ours does, the limiter has to be disabled. So we have a little jumper here we've disabled before we do this. That way the limiter is not affecting the accuracy. And so what we do is we take a reading right before we go into the BBDs. So the last step before we go into the BBDs, sometimes that's after the compander generally, or after the filters, and that I've set to minus 15 dBV, decibels below a volt. And now I'm going to look at the first signal after the compander. And the idea is that I want it to be about the same voltage. Now we have two BBDs, so I'm just looking at the first BBD. I've switched it to BBD-1, and you can see I've gotten about a dB and a half of gain. I like to have about a quarter dB of gain because at this 22 kilohertz setting, that's when the BBDs are the most efficient. So I know that in other settings it will be less efficient. So I'm going to set this. You can see now I've got it at minus 14.9 on the output, and I started with about 15.10. So I've got about a quarter dB of gain. That's on the first BBD. Now we're going to switch to the second BBD and do the same thing. I like to have a little more gain on the second BBD. I believe it sounds a little bit better. And so we're going to set this one to about just below 14.8. So switching between the two BBDs, I have on the second BBD 14.78. And on this one, 14.9. And in dB, it's minus, so the smaller the number, the more signal. And then to compare back to the beginning, we have 15.10. At this point, the BBD is fully calibrated. The only thing we have left now is to check the frequency response and to check the other functions. So, using the oscilloscope, I'm going to look at the output and turning the gain down. This is my wet signal. You'll see a little bit of BBD distortion. I can compare it to the dry signal for gain. We do have a limiter in here, so as I crank the gain, you'll see that you can see the classic diode limiting of the dry signal and the wet signal. And I can check to see a little bit difference. Again, you can see why triangles is nice because I can see the clipping at that point. At that point, I'm going to go over to my ARTA program, and I'm going to look at the frequency response in ARTA. And you can see I've got distortion going on as my gain is high. So I'm going to bring the gain down. And I can see my frequency response in the dry signal. And now I can see my frequency response in the wet signal. And now we have a tilt EQ. So I'm going to check the high. And now I'm going to check the low. I'm then going to make sure that both BBD1 and BBD2 look the same. There's a little bit more brightness when I just have one BBD on. You may be able to see that, you may not in this video. And then I'm going to check that as I shorten the delay time. I do lose a little bit of gain, but not too much. Everything stays good. And now the hard one is when I use the longest delay time. And that looks good. Now all I'm left to check is the feedback controls, which you may have noticed I did not check before. So we're going to make a really long delay time here. And we're going to watch on the scope that as I put a signal in, I'll turn up the gain here a little bit. As I put the signal in, you can see one feedback happen. I'm going to use my foot on the expression pedal, and as I do it again, we can see multiples, and they're staying the same. The next thing I check is that if I make a very long delay time, that when we go into, that I quickly go in and out, and that makes a little, that is the feed through, and so what I'm checking is the tails mode in that case. And now the next thing I'm going to do is make sure that it works from the control here. And it does. I can quickly switch the switch and watch the delay time double. And then I'm going to check the another form of the tails mode. And no signal should get in tails mode. We'll try this again. No signal should get in tails mode until I flip it off. And that's the end of calibrating and testing a ADG-1 analog delay. Thank you.